The first step that you will do in the lab is measure the density of the sand. To do that, we're going to use this mold. It's called the Proctor mold, and the volume of this mold is 944 centimeters cubed. So what we're going to do is what you will do in the field, which is basically work with this sand cone apparatus. And this has a cone and a valve that if you move it, you can turn it off or on. So I'm going to make sure that it's turned off, and I'm going to place it on top of the Proctor mold, and I'm going to open the valve, and I'm going to allow the sand to fall through. Things that you should not do. You should not move the cone around. You should not change the height of the cone. You should not start tapping on the screws. Basically, do not do anything that will disturb the density of that sand. And you will do this until basically you have completely filled the container and sand is just moving it's just falling through. Once you have done that, you will grab your straight edge, and with one smooth swoop, you will smooth it. So the volume right now it's 944 centimeters cubed. With a paintbrush, you'll clean the equipment around, and you can get the mass of the mold plus the sand. Therefore, you know the mass of the sand in this container. If you know the volume, you know the density of the sand. You will do this 3 times and make sure that you have repeatable data, and you have completed the first step for the lab portion. The step that we will do in the lab is to find out how much mass fits in the cone for the sand cone method, because we need to know that so we can convert to volume, and we can account for that mass or volume when we run the experiment in the field. The best way to do that is to actually do what we will do in the field in the lab. So when you go to the field, you will work with this steel plate, and if you see, this steel plate has these little legs that are very handy because they will help you set the plate in place. However, in the lab, they're not so great because there is an opening between the plate and the table. So one quick trick to do that is just elevate the steel plate so it doesn't, you don't have that problem. One thing that I like to do so that I don't have sand going everywhere afterwards is I like to place a plastic bag in between my book and the steel plate. And that way, later on, I can just grab onto the bag and move the sand around. So what I'm going to do is I'm going to have my sand cone apparatus. I like to fill it at least halfway through. When you go to the field, it's probably a good idea to fill it up to the point where it starts curving. And I will take the initial mass of this sand cone apparatus. Once I know the initial mass, what I'm going to do, making sure that the valve is closed, is I'm going to turn it upside down, just as I'm going to do it in the field, and then I'm going to open the valve. And I'm just going to let the sand flow until basically there's no more flow anymore. At that point, I will close the valve, and I will measure the mass of the sand remaining. The difference between the 2 values will give me how much sand fell through, filling this cone at that little lip in the plate. That will give you the second number that you need to get in the lab, which is how much mass does it take to fill that cone plus that little lip.